For the past few decades, an incredible amount of structured radio signals have been emanating from Earth into space. This noise has long since traveled to many other star systems, but only one of them is at a relatively close distance from us, about 437 light-years away. That's Alpha Centauri. The Alpha Centauri system consists of three stars. Two of them are very close and appear to be a single source of light. The distance between them varies from 11.2 to 35 astronomical units. The largest star, Alpha Centauri A, is a main sequence star. It is fourth in brightness in our sky and emits 1.5 times more light than our star. It is 8% heavier than the Sun and 25% larger. There is no confirmed evidence that Alpha Centauri A has exoplanets. Only in 2021, in the infrared spectrum, recorded some evidence of the presence of such an object with a mass between 935 Earth masses. Presumably, this space body rotates from the star at a distance of 1.1 AU, making a full revolution in one Earth year. All this data still needs to be confirmed with observations from ground-based observatories or with the James Webb Telescope. Alpha Centauri B is also a main sequence star, but it is 12% smaller than the Sun. Its surface temperature is just under 5,000 °C. This accounts for the star's orange color and luminosity half that of the Sun. Although it emits a lot more energy in the X-ray range than other stars in its class, Alpha Centauri B is unstable, so flares and outbursts are not uncommon. With exoplanets orbiting around it, the situation is the same as with Alpha Centauri A. In 2012, scientists analyzed the luminary's own motion and assumed that close to it is a planet with a radius slightly smaller than Earth and an orbital period of 12 days. Only 3 years later, a mathematical error was found in the calculations. The third star of the Proxima Centauri system is a red dwarf. Its mass and diameter are about 7 times smaller than the Sun. Its surface temperature is over 2,700 °C, but it's the closest of the three to us. It's 425 light-years from the Sun, hence its name, which is Latin for closest. That distance is shrinking even further with time. In about 2,600 years, it will be down to 3 light-years. Proxima Centauri is 13,000 astronomical units away from its brighter neighbors. But in 300,000 years, it will have tripled that distance. Around its common center of mass, Proxima Centauri makes a complete revolution in 547,000 years. It has as many as 2 confirmed exoplanets and 1 hypothetical one. And studies in the infrared suggest the presence of a ring of dust around the dwarf, as well as many small cosmic bodies such as asteroids. The first planet, Proxima Centauri b, was discovered using the radial velocity method in 2016. Spectrographic studies by the VLT telescope in 2020 were able to confirm its existence. The exoplanet makes a full revolution around the red dwarf in 11 days. According to calculations, its mass is greater than Earth's by about 10 to 20%, and its radius is about 1.3 Earth radii. Computer modeling showed that Proxima Centauri b receives from its luminary 1.5 times less light energy than the Earth from the Sun. Thus, the average temperature on its surface is 39 degrees. So there's a good chance that liquid water exists in some areas of this exoplanet. Except it's so close to the red dwarf that it's probably in its tidal grip and it's turned to one side. If the exoplanet had a dense atmosphere, the temperature variations on its surface would not be so drastic. Only Proxima Centauri, like all red dwarfs, flares up frequently, spewing its stellar matter into outer space. So this ionizing radiation is detrimental to the atmospheres of its planets. Proxima Centauri b could be protected by a powerful magnetic field, only it is unlikely that it possesses it. The existence of a second planet in the red dwarf Proxima Centauri proved in 2020. From the center of the system, it rotates in 1.5 astronomical units, and its orbital cycle slightly exceeds 5 years. The mass of the exoplanet is estimated to be between 6 and 8 Earth masses. The radius has not yet been determined, as well as not established to what class it is attributed to, super-Earths or mini-Neptunes. The flight to Alpha Centauri. Its distance from the red dwarf causes a low surface temperature of 234 deg. It is possible that it has a ring system the size of 5 Jupiter radii. The existence of a third planet in Proxima Centauri has not yet been proven. But it is assumed not far from the dwarf there is a very small exoplanet with a mass of 0.25 of the Earth's. The year on, it should last about 5 days, and the surface temperature reaches 87 degrees C. Interestingly, for the first half of this century is planned program Breakthrough Starshot, which will send to Proxima Centauri 1,000 microprobes no larger than a centimeter in diameter, and take out of there on a thin sail, inflated from the Earth pulses of ultra-powerful laser. They will fly at 20% of the speed of light and will spend 20 years on the road. It will take another 5 years for the data they collect to arrive on Earth. In the nearer term, the Ptolemy telescope is expected to be launched into orbit to study only Alpha Centauri and its closest stars. Thank you for watching this video to the end. Don't forget to like and subscribe to the channel to learn more about space.